Hello, this is Conan Horrors, and this is not Kerbal Space Program. No, right now I'm playing Human Resource Machine, which is a really fun game well, you'll see here in a minute. Now I'm just going to jump into a random level that I've done already. Rainy Summer, that sounds good. So, the point of this game is to perform actions. Oh, this saved what I've done before. Uh-oh. Well, okay, I'll just explain the concept a little bit. So you're this little guy, and you're supposed to perform this series of tasks using instructions. So for each two things in the inbox, add them together and put the result in the outbox. You got a new command. It adds the contents of a tile on the floor to whatever value you're currently holding. Okay, cool. So I guess what I've already built is take from inbox and copy it to 0, then take from inbox and add it to whatever's on 0, then take that value and put it into the outbox and loop. Just continue doing it. So we'll hit start and go, right? See how this all works. Boom, boom. He adds, puts on the out, and continues. This is a fun little game. It teaches logic skills, right? And, you know, it's amazing how much you can learn from just a really fun video game like this. It wasn't, I don't know if it was really designed to teach anything so much as to have fun, and then teaching came second. I don't know. I mean, it's obviously teaching the player something was obviously intended, but I don't know at what point it was intended or how much it was supposed to be intended. So what are we teaching in this game? Well, would you believe me if I told you that we are teaching the players, these kids, how to program? All right, so let's go into a level that I have not completed yet. And he's laughing at me. Uh-oh. Positive attitudes were determined to increase productivity. Oh, good. And are now therefore mandatory. Yes, I love this self-aware humor. Management is watching. Okay. So our task is send each thing from the inbox to the outbox, but if a number is negative, first remove its negative sign. Okay. How can I do that using these commands? I have a jump if negative. I have an add and a subtract, copy to, copy from, inbox, outbox. Interesting. So I think what I can do is subtract the value from itself twice, and that will give me the positive version of what it is. That's how I'm going to try it. So I'm going to do inbox, right? Then jump if negative. Or no. Yeah, let's do jump. I'm going to get 0. 0 is going to become a problem. So in here, between the jump and where the jump executes to, is where I'm going to put my if it's negative function. No. Okay, I got it. I got it figured out. So jump if negative. This will go down to some instructions, and then the jump will bring it back up to the very beginning. Okay, now I can copy to 0, right, and subtract 0, and subtract 0. Then, yeah. Then this will come back up here, jump if negative. It won't be negative anymore. So I can go through that instruction again. Well, actually, let's avoid running instructions over and over. And in fact, we'll avoid that all together there. Okay, so this is skipping stuff, and this is coming back to the top. Okay. Now, just to outbox, right? I think that'll work. And then when we reach the end... Okay, here we go. Jump box. This will come back to the very top. Right? Let's see if this works. So the first value is 3. He puts it out. Fantastic. It's a positive value. This is a negative, so he puts it there, subtracts, and then subtracts again. We get a positive 1. Fantastic. Okay, 0 is technically a positive value. Good. Good. 0. Negative 2, or subtract negative 2 is 2. Negative 9 just should become a 9. And voila, there it is. And a 3 is positive. Fantastic. Well done. Good job. Sweet. I did a very good job on that. Uh-oh. In 36 or fewer steps, your solution completes in 39 steps on average. Whatever. I'm okay with that. Back to elevator. Okay, so that's Human Resource Machine. It's supposed to teach computer programming, but how exactly does that? Or how exactly does it do that? Well, I'll go to another video game, and we can explore this idea a little bit further. Okay, here I am in another video game. This is called TIS 100. It stands for Tessellated Intelligence System. And here's just the first level. Click on that and create a new program. That way I'm not loading something that I've done before. And the idea here is to read a value from in.x and write the value to out.x. Okay? Then read a value from in.a here and write the value out to out.a. Okay, which is there. We have to write up our commands. These commands are already written for us, so I can just copy essentially over here. Move up left. Okay, then move right down. Move up down with a comma. We need the comma. Come on. And move up, right, move left, down, and that should work, right? Let's run it. Papa! Yay, we did it. Okay. So this is also computer programming. And why such a very, well, honestly boring UI? Well, because this game is all about the programming. So let's create another new program. Read a value from in A, double the value, write the value to out A. Okay, I can do that. It might use a couple more of these processors, but whatever. So the idea is to teach computer programming, or at least to have fun with computer programming. It gives you constructive things to do with actual computer programming. Now, those of you who do program, I'm sure many of you will say, well, Conan, this doesn't look anything like the programming that I do in C# or C++, or in Java or JavaScript or PHP or any of these other languages that you might be using. Python is another good example. Well, that's okay. Fair enough. I agree. It doesn't look like any of those things, but there is one language that it does look like, and I'll show you that here in a bit. First, I want to solve this puzzle. So let's go with it. I'm pulling the value right up, or sorry, move up. We'll bring the value, or take the value to the accumulator. Then add accumulator to accumulator, right? Okay. It automatically goes into the accumulator, and then move accumulator down. Move up, down, move up, right, and move left, down. So that should be our program, right? Let's go for it. Running faster than anybody could really keep track of. But it doesn't look like it's producing any errors. Fantastic. Yay! Yay, yes. Okay, well, let me show you what language both of these games are teaching us. Okay, so here I am in Microsoft Visual Studio. I've programmed or built this program in C++. As you can see, I've already run it to make sure that it works. Anybody who's a programmer knows that feeling. So right here, I have what is called assembly code. And what's happening is this assembly is running, and anybody who knows what assembly is knows that it's just a readable representation of binary. If you don't know what binary is, I have linked in the description below a video on YouTube that you can go and watch, and it will explain what binary is. And I've also attached another video, or linked to another video, that briefly describes what assembly code is, if you want those resources. But if you know what binary is, you're fine. It works. So assembly is just a readable representation of binary. What's happening here, and this should look familiar to the games we just played, right? So move, spelled exactly the same way, and then add, but this takes two parameters. Remember how I was getting confused and typing 2 and the game told me I was doing it wrong? Yeah, that's because in real life we use 2 parameters. And in the move uses 2 parameters as well. So EAX is a register that is inside of the processor. It is a very quick, very easy register to get to. It's right there inside the processor, so there's no, well, there is, but there's limited delay time between reading and writing to that register. It's very, very, very fast. Coincidentally, there's not very much memory inside the processor, discounting the cache. If you count the cache, then it becomes larger. Anyway, just a very basic, program. Two files. I'm just calling the header file in here, and this header is just, including the I/O stream so that we can input and output data, and using the standard namespace. And then I'm defining a double value function, which is then further defined here and called here on this line. So we're just going to take a number from the user over and over and over until it is 0 or lower. Alright, here we go. 10. What's the double of 10? 20! Fantastic. And is that what it's supposed to be doing? Yes. So move from V to EAX. Okay? Then add into V the value of EAX. So what this is doing is saying the value that is in V, and in this case it was 10, right? So the value 10, which is in V, was moved into EAX. That means that during this process, I'm just going to write this down here, EAX now equals 10, and V equals 10, right? Then add V EAX. So what that's doing is it's taking 10 from EAX and adding it to V. And this becomes in V 20. So EAX is still 10. Then we return the value of V, which is now 20. Right? That's what's happening inside the processor. I could, in theory, try to make this even faster. And I haven't actually tested this kind of thing before, But let's try it. Let's try not even having this move function. Just add v to v. I think I'm going to get an error because I think it's expecting a register or a memory location. But let's try it, right? Yes, I would like to build it. Uh-oh, yep, got an error. And it's because, yep, improper operand type. So yes, it is expecting a register. I can't make it run any faster, so move into EAX the value of v. And then add into v EAX. Sweet. And ta-da! 10 becomes 20, 1 becomes 2, 684 becomes 1368. Fantastic. Now, if you want to have a lot of fun, you could try this. Extra points to anybody at all who can figure out what's going on here. I'm not going to tell you in this video, but if you can figure it out and put it in the comments below, extra points to you. Anyway, I'm Conan Horace. Have fun.